Hi, it's me, Carrie. It's your teacher. Hi, online college algebra class. Some of you have been asking questions about how to come up with the equation for a piecewise defined function if all you have is the graph. So I thought I would try to explain that to you if I could. So you know that the structure of writing an equation for a piecewise defined function looks like this. And then there are two columns, and I think it's really helpful to think about the way this is put together like this. The first column tells you what to do. What to do. And the second column tells you when to do it. And the when to do it is usually given, well, it's always given as x intervals for x. So this piecewise defined function has three different pieces to it. So we're going to have three different lines here, one corresponding to each, well, piece. And then for each piece we have to talk about what to do on that interval and what interval we're going to be doing it on. So when I'm doing this, first thing I do is identify what the intervals are. So this thing looks crazy. And it looks crazy because it's got a bunch of breaks in it. It actually has two. One of the breaks is right here, where the function changes its behavior from just doing this to doing this. And it changes its behavior again right here. So the dashed lines that I've put on there establish the intervals of behavior. The interval in the middle, let's look at that one. It goes from x is equal to -2 up to x is 2. And to write that with an inequality just looks like this. So the numbers out here are in the same order that they appear on the number line, so the inequalities are always going to point to the left. Since this dot is colored in and this one isn't, you put in equals here, but that's not a big deal. Let's look at this interval. The first interval here goes up to -2. That's where the next one begins. And the left-hand end point of that interval is at -4. So -4 on the left, -2 on the right. The thingies always point this way. The inequality symbols always point to the left, and since the dots are colored in, they'll both get equals. And finally, the last interval, the one on the right, starts at 2 and just goes. And so if you want to talk about all of the numbers to the right of 2, the easiest way to write that is like this. And I'm not putting an equals under there because this circle is not colored in. So those are the intervals. And then almost not related to them at all is what goes on each of the intervals. On the first interval, that's this one. So you could call this like interval number 1. This is interval number 2. This is interval number 3. This is number 1. This is number 2. Oh, look at all the numbers. There's too many numbers. So on the first interval here, the graph is behaving like the constant function y is equal to 1. So what do? You don't do much. You just let the value of the function be equal to 1. I forgot I have a fat marker here. So y, f of x, is equal to 1, and that's what you do on the first interval. What do you do on the next interval? Well, the other two fragments here are both pieces of lines, so we just need to be able to write the equation of each of these lines. So lines have equations that look like this, right? Y equals mx plus b. So we just need to come up with the m and we need to come up with the b. The b here is easy. That's the place where it crosses the y-axis. That's equal to -1. What's the slope? Do you remember the rise over the run? So to get from this point to this point, you go over 1 and up 1. The slope is equal to 1, so m is equal to 1. So the equation of the line is 1 times x minus 1. So that is what to do on the middle interval. On the last interval, It doesn't cross the y-axis, so we're going to have to be a little bit more particular here. Let's see. If we just want to track the slope, I see 2 points on here. Here's one of them, and here's the other. So from here to here, that goes from positive 3 all the way down to the x-axis, so that's a height of 3. And then to get from 2 to 5 is also a width of 3. So the slope here is 3 over 3, but I can tell by looking at it that it's negative, so the slope here is -1. So I need to come up with the y-intercept, but if the slope is equal to -1, then this line is tilted at a 45-degree angle, and so if it hits the x-axis at 5, where do you suppose it's going to hit the y-axis? Right, 5. So b is equal to 5 here also. And so that means the equation of this line, y equals mx plus b, -1x plus 5. So -x plus 5. So this is our equation of this piecewise defined function. I hope that helped. I'm sure you'll let me know if it didn't. Thanks.